Gonna keep getting ready for your check-in coming up. Focusing on those two standards, working with sequences. And for that second one there, not really doing the exponential functions today. We did real well with those, and we'll review them later on, but gonna focus on just the quadratic functions. All right, so first thing, when we graph a quadratic function or have a graph of the quadratic function, you can have it look like this blue one here or look like the red one there, where it's the U shape or upside down U or smiley face, frowny face. Anybody remember which one has the positive A value? What do you mean by going up? Yeah. I just want to make sure you didn't mean like the curved part was going up, you know? So the blue one here, we're going to have like a positive AX squared. For the red one over here, negative AX squared. Your coefficient is going to be a negative on the X squared there. I always think of it as, the positive one's a smiley face, the negative one's a frowny face. To me, that's kind of like a little easier way to always get that right. We have the green dots. Those are x-intercepts, zeros, solutions. Basically, any of those three words, probably a couple others too that aren't as common, but those are the main three ways you'll see that. The orange dot across. When you have the whole function written out, that is going to be your C value each time. So if we got the AX squared plus BX plus C format for them, the C is your y-intercept each time. And then you have the vertex, which is at the bottom tip, the minimum there, or the maximum at the top of the curve. Anybody remember how to find the X value for the vertex? So to find the X value when you have the vertex, you're going to do the opposite of, that's B, over 2A. Okay? So your vertex X value is opposite over 2A. That sometimes is written as an equation, X equals whatever that number is, and called the axis of symmetry too. Any questions on any of that? All right, so that graph's kind of tiny, but we got a graph there. Start with the easy parts usually. That's a smiley face, right? So that means we got a positive A value. Well, that's zero help in this case, but that's always the first thing you could check, because a lot of times that does eliminate two answer choices. Doesn't help here though. The y-intercept kind of runs together a little bit, but the y-intercept's right there at 7. So what can I? B and C. B and C both have y-intercepts of 3. That's what knocks them out of this. All right, so the next easiest part usually is that vertex, the X value. Opposite B over 2A. So we're going to test it with the 2 that's left. It's just a little bit of math you got to do. Like, it's not like anything super tough. Opposite of B means I got to get positive 8 over 2 times my A value. What's 8 divided by 8? 1. So A is working. We got to check D also just to make sure, right? So opposite B over 2A. Obviously, that's not 1, right? So that's one way you can kind of go through those. You just kind of want to like tick your way through to see which things match up. This one doesn't have any zeros or x-intercepts to it, so you don't really need to be able to factor it. Factoring works when it's crossing the x-axis. Speaking of factoring, you gotta remember doing the magic X. So when we do the magic X thing for factoring the quadratics, you times C on top and our B value on the bottom. They need to multiply to make AC and add to equal B. So we're looking for the two numbers that do that. Once we have those two numbers, we divide by the A value. And that's going to give us like our factors. All right. Do you literally have to make the X? No. Sometimes it's just a way to kind of help organize it though. So on top I got A, C. What's A times C in this one? 3. The bottom's my B value. What's my B value? 11. All right, so we need two numbers that add to make 11 and multiply to make 30. Everything's positive, so we got positive numbers. So what two numbers are going to add up to 11 and multiply to make 30? 6 and 5. If you didn't know that, you just kind of list the factors of 30. Like, you got 1 times 30, 2 times 15, 3 times 10. Then you do get to 5 times 6. 5 times 6 is the only one that adds up to 11. All right, we got our 5, we got our 6. Then we divide by the A coefficient. So we're dividing by 3, and we're going to keep them improper fractions. Okay, so 5 over 3 stays 5 over 3. 6 over 3, we're going to change that, simplify it. We got 2 over 1. All right, everybody good with that part? Now, we got a couple different ways we can write that. If we are looking for the solutions are factors here with the sign changed. So we got a negative 5/3 or negative 2. So if we were to graph that, that's where they would cross the x-axis at those two numbers. If we were writing it out factored, like our backwards FOILing kind of thing there, the denominator is the coefficient. So 3x on the one on the left, and you're either adding or subtracting your numerator. So for the one on the right, we just got a 1x plus 2. Any questions on that? What you're doing a lot of today is we're going to be looking for these solutions though, okay? So you got to get the magic X going. Once you got your factors on the side, change. Y'all give that one a try. Find the solutions. You should have negative 36 on top, negative 9 on the bottom. If you don't, fix it. When the top number is negative, that means the sign will be different. And if the bottom number is negative, that means the bigger, at least to start with, not for your solutions. All right, we got it.
2x plus 3 and x minus 6.
I want the solutions. Dulce? Yeah. We got 6 or negative 3 over 2. And you're not wrong. You factored it correctly. Okay? When it's the solutions, though, I'll just show it. All right, so we need the numbers that multiply to make negative 36, add to make negative 9. In this case, that's going to be negative 12. All right, 3 times 12 is 36. Negative times 5 makes a negative. Add those together, sign of the bigger number. Signs are different, we subtract, so that's how we get the negative 9. We divide A, 1, and we got 3 over 2. For our solutions, we're changing the sign on those. And that's going to be what the answer is, or what we're looking for here. X equals positive 6 equals negative 3 over 2. The reason it works that way, when we're looking for the solutions, we got x minus 6 and 2x plus 3, like Aiden said. We're looking for the x-intercepts, where they cross the x-axis. So we're looking for basically where they're at 0 for equal to 0. To make it equal to 0, when you're multiplying two things, one of them has to be 0. Well, what do I do to that to make it 0? Positive 6, right? This one, to make it equal to 0, I'll go ahead and work this one out to show you. But what you would do is you subtract 3 side, so you got 2x negative 3 over 2, we were saying. So your solutions are the zeros. That's like changing the sign from the factors. So 6 or negative 3 over 2. And then depending on the context of the problem, like if it's a word problem, it might have to be the positive number. Questions on that? All right. Sequences then. Y'all remember these a little bit? We can have recursive or we can have explicit sequences. The recursive ones look like this on top. They tell you the first term. So what's my first term? 2. And they tell you the pattern. So what's my next term? 7. But that's there when you have A with the subscript n minus 1, that means you're using the previous term. Before it, which now would be 7, and we do the math it says. Plus 5, so we got 12. Everybody kind of follow? The explicit ones are a little bit different. Anybody think they can tell me the first term there? 2. Who's not sure where 2 came from? So when you're looking for the term, if we want the first term, we put a 1 right there. 5 times 1 is 5, minus 3 is 2. So now if I want the second term, we're going to put a 2 there. 5 times 2 is 10, minus 3, 7. If I want the third term, 5 times 3 is 15, 15 minus 3. Well, you can see these are the same sequences, just written different ways. Everybody kind of follow? The explicit ones basically work like linear functions, where you got like y equals mx plus b. Whatever term number you need, you're plugging in basically for the x value of the function, or it's usually going to be n on these. Find the first 4 terms. Riley? All right, everybody good with those? Whatever term number you need, we're putting it in for n. It's kind of like we would have like a table where the term numbers are your x value and the term in the sequence is the y values. All right, so if we made it a xy table, that's the first term, second term, third term, fourth term. Everybody kind of follow? And we just plug in. So if I needed the 100th term, who can give me the 100th term? Yeah, 403. I picked an easy number. I didn't give you like the 87th term, but we should be able to do the 87th term like with a calculator with a little more time, right? You just plug in whatever term number for the n value. Easy to get the term.